Okay, class. Today's class we'll be learning about integration by parts, or something that lecturers always abbreviated as IBP. Integration by parts. Okay, what does it really mean? When do we really use it? Here, let's take a look for a few examples. Let's say if you're given something like this. How do you differentiate? Substitution? Do you want to look why substitution fail? This one, substitution will not work. It will only work if this one, the power is, if I differentiate, I got in front. In this case, if I differentiate the x, what do I get? 1, this is not the same as this one. Okay, so substitution will not work. I can give you more, such as, what about if I give you something like this? X ln x. The normal substitution will not work. In fact, if I even give you ln x, let's go further. X plus 1 cos x, it will not work. Normal substitution, normal integration or normal substitution will not work. In fact, if I go further down, something as simple even as ln x, nothing will work. This is where it's best for you to see if you have more than two things. What do I mean by that? More than two types. This is different type, this is different type. Exponent type, this is linear or just algebraic type. This is, some people call it algebraic, some people call it polynomial. Some people call it algebraic, some people call it polynomial. This is exponent. I am not going to argue with people, so I say L or poly. This one is ln. This one is L poly. This one is trigo. In fact, if you are given a loan such as this one ln, a normal integration or normal substitution will not work. So in this kind of case is when you are given two types. I want you to see there are two different types. Except for one another rules. Yes, this one, sir, I can see there's two types, sir. But normally I'll say to people, the moment you see yourself a ln, although they are by themselves, this one by themselves, then it's a given IBP. I repeat myself again. We use IBP when I see there are two different types. Okay? Or just plainly when I see ln, then just it means directly IBP. You use IBP when you see two different types. What are those types? Yeah, that's a good question. I'll say algebraic or poly. Two exponent, trigo, and ln. Or just directly see when you see ln. When you see these two things, then automatically it means you need to use IBP. Understand? Although there are some exceptions in other case. I'll show you. Let me remind you the exceptions for this case. it's a tiny exception. Let me show it to you before we go further in IBP. These two are not IBP. In fact, these two is substitution. Can someone tell me why? What's the difference of these two? So this one got power, so what's the big deal with that power? If I differentiate, I got the front part. If I differentiate, I got the front part. Okay? In these cases, I differentiate, I did not get there. I differentiate, I did not get there. Are you okay with that? So for these two, you need to use let u equals to x squared. Same goes for this one. This one I have explained in the previous class. This one I haven't explained yet, but the concepts are the same. You get the same answer. Okay, so I'm not going to go further down. Right, certain lecturers, they have a style which I have to admit last year I used it, but I don't really like it. How do we know the arrangement of which one to integrate, sir? Well, some lecturers use last year I used the ln pad, ln polynomial exponent trigo. Some people use a lazy. Is it lazy? I forgot what it means. Ln algebraic. I forgot these two because I don't use them. All right. You can memorize things, but sometimes you're carrying too many things in exams. So I'm going to explain to you a very simple concept, and I hope you get it as well. If you differentiate x, what happens? If you differentiate ex? Yes. So which one, if you differentiate, makes your life simpler? X. So we're going to use this one. Let me rewrite them again. Okay, differentiate x, you got 1. You differentiate ex, you cannot. You just get ex. So which one makes your life simpler? X. Differentiate x. Differentiate ln x. Okay, I'm sorry. Can you integrate ln x? Okay. So the moment you see ln, you need to go. This is the one that you want to differentiate. Differentiate x plus 1. Differentiate cos x. Which one simpler? X plus 1. This one. You see ln, then it means automatically differentiate ln. Alright? You see ln, automatically it means differentiate ln. So, in my principle, it will be for integration by parts. It's either differentiate things that make your life simpler, or the other one, you see ln, differentiate ln. Okay, these are the two rules that you need to use. I just find it to be a lot easier. And let me know by the end of the day. Why you want to differentiate ln? Because can you integrate ln? You cannot. You cannot. So that's the whole logic behind it. Okay, so let's go through them. Are you ready? Okay, some lecturers, they use a formula way of memorizing, but I do not use it that way. As you know me, I love patterns more. And even if I have tried this question a year later without any revision, I still can do it because I memorize the pattern. I don't memorize the formula. Okay, of course, firstly, given or not, you need to know which one is u, which one is v, because you see two terms. Okay, it's the same as differentiation. And as I mentioned to you just now, which one is simpler if you differentiate? X. So you go here, you write down u equals to x, u prime, that means you differentiate, equals to 1. Okay, this one here, I go with v. In fact, I go with v prime. V prime, what does it mean? Normally, it means you differentiate, right? So v prime to v, what happened here? Basically, here you integrate. This one here, you means you differentiate. Or sometimes I write down differentiate. Sometimes I write down integrate. Okay, you want to integrate EX, what do you get? Integrate EX. You get the same as EX. Are you okay? Okay, now look very, very, very carefully. Let me repeat before I go further. How do I know which one to use? Differentiate which one? That makes your life simpler. The one that we cannot, what we do? We integrate. Okay, now look very carefully. I'm taking this one. I'm taking these two, and I multiply them up. So x times EX, x EX, okay? And then the next one, in the middle, I put minus. Okay? And after that, I do integrate. I want to integrate what? I'm taking down here. 1 times EX, EX, dx. Because we have algebraic x left, we put dx here. You remember the pattern? Okay, from the beginning, how do we do? Differentiate which one? Your life simpler. Okay, x. What do we do with EX? We integrate. So you differentiate x, you integrate EX, you got until here. Okay, and then from here, what do you do? Take x, EX, put them there. In the middle, what do you do? Minus, and then you integrate. Integrate what? Down here, 1 EX. So in another way of telling you, we do not use this at all. We're only taking these three patterns. Okay? You can memorize the formula if you want to, but normally whenever the teacher asks the students back, what's the formula of by parts? People could not think about it. So you just might as well memorize something that you can remember. Patterns easier. Okay, integrate EX, what do you get? EX as well, very good. X, EX minus. Are you okay? Very good. I was waiting for it. Okay, now let's try it again one more time. I'll show you another examples. Let's say you're given something like this, x plus 1 cos x dx. How? How do I do? Okay, wait. Firstly, I'll see myself there are two different types. Okay, and then which one? How do I do? Which one to differentiate? Yx plus 1 makes your life simpler. Differentiate cos x, you still got sin x. Nothing simpler about that. So we differentiate 1, we integrate 1. So u x plus 1 differentiate 1 v prime cos x integrate sin x. Very good. And then how do I continue from here? I do this Tetris here. Okay. I times them up. X plus 1 sine x. What do I do next? I minus. And then I integrate what? 1 sine x. Integrate sine x. Negative cos. Negative, negative. Positive cos x. Yes, I can hear you. Some people got pissed off with me by now. Plus C, sir. Understand? Easy? Okay, let me increase the difficulties a bit. So you will not be shocked when you see it later in your life. What about if I give you something like this? What do you think? How do we do? Firstly, why this one is by parts? Tell me. Two different types. And then what do I told you about exponent? Differentiate the power. You got in front? You don't go in front. Okay? So that means it's by parts. You're good to go. What's the pattern again? Two different types. If I see differentiate the power of x here, do I get in front? I don't. So it's by parts. Okay, which one should we differentiate? Why x2? Well, what's our rules just now? Which one we differentiate? The one that makes your life simpler. Okay, let's say if I differentiate ex, what do I get? Does your life become simpler? No, it's not. It's just the same ex, the same troublemakers. Okay, so if I differentiate x squared, what do I get? Does your life become simpler now? Sort of. Okay, but I want you to know, if I differentiate ex, I get ex. It's the same things. Not going to make your life any difference. So we differentiate this one. Remember, you have differentiation, you have integration. So differentiate x squared to x, integrate ex, ex. Okay? So what do I do now? Z. Well, actually, I remember this one is, what you call that? Tetris more. Or maybe, see a dinosaur there. Or maybe a horse, a dog or something. Okay, how do you continue? And then integrate what? To x, ex. See, it's not that hard to memorize pattern, right? Okay, now differentiating 2x, ex. How? Do the same thing? What do you mean by do the same thing? Integration by parts. Why? Because you see, two different things. Very good. Come again. Differentiate ex, integrate. Right, differentiate which one? Okay, this one here, yeah, you are right. It's the same thing. It's the two different types. So it's a signal for you to use by parts. And you can see if I differentiate the power x, I got one which is different. So yes, this is what we call double by parts. Trust me, it's not the worst yet. Okay, so how should we continue from here? Which one should we differentiate? Differentiate to x. Why do you want to differentiate to x? Differentiate to x, we got 2, which make your life simpler. Okay, if you got the concept, it's good. So now if we differentiate to x, so we got ourselves 2, and we integrate ex, we got ex. Are you okay with that? So now, how? Still do the same dinosaur thing. 2x ex minus, sorry about it, minus what? Integrate 2ex. Are you okay with it? Of course, you can say, sir, we drop this whole thing, sir. Yeah. Integrate 2ex. It's the same thing, 2ex. And then I can be a bit quick here, negative times here. Negative, negative times here. Positive. Are you okay? Okay, very good. Ta-da! Not that bad. Are you okay? I'll give you one that I want you to try by yourself. Sorry, it's a bit cruel there. Okay, alright, this is a little bit of reshoot because I forgot to record just now. Okay, how do we integrate x ln x? I need to reshoot, okay? This is reshooting. Differentiate ln x, why? Because you cannot integrate ln x. Okay, if I do u equals to x, if I choose to differentiate x, I got 1 integrate of ln x. This one is actually impossible. So this technique will not work. So what we should do is actually we should differentiate ln x. So if you see ln x, that means you need to differentiate it straight away. Oopsie. So give you x, 1 over x, and then we integrate x. Shh. You're still on camera. Okay, so we go from here. We take this one as usual, nothing much difference. And then minus as you can see here, I can simplify. Integrating x over 2 will give you x squared over 4 plus c. I think I missed my ln x. Sorry, I'm a bit fast here. I was being fast, okay? Alright, good enough. Okay, but what about if I ask you to just integrate ln x? if you see ln x, integration of ln x, it means immediately it's a by parts. So the idea is the same because you need to differentiate ln x. You cannot integrate ln x. Over here we integrate 1. It's 1 times ln x. Okay, so we got until here. The process are the same. X ln x minus integrate. Copy this one here. 1 dx, integrate 1, give you x. Plus c. Okay, the bit of a disclaimer over here. Integrating of ln x will give you x ln x minus x plus c, and some lecturer says, hey, you're allowed to integrate this one directly without using the formula, without using this whole concept, but some lecturers disagree with it. I personally, I agree with it, unless the question says no. There's some question that didn't allow you to use this, but I'm going to check with the head of examiner one day, inshallah, check whether this is allowed or not. But I personally, if I were given another type of questions, let's say something like this, I will go cuckoo. I will lose my confidence that I will do the whole thing again. Which, okay, this is the next questions that you need to try. Okay, viewers, you might want to try this question first by yourself. I'm going to show the answer straight away because I'm running out of time. Okay, so this one, which one you differentiate? Ln 3x minus 5. Okay, we're about to run out of time, so I'm going to be a bit quick here. 1 over 3x minus 5, differentiate inside. You got times 3. Or times 3 here lah. Okay, sorry, a bit fast there. What do you want to integrate? Integrate 1. X. Okay, now you combine them up. X ln 3x minus 5 minus integrate of what? X 3x minus 5 dx. Are you okay? How do we integrate this one? Why by parts? What different? This is algebraic, this is also algebraic. There's no exponent, there's no trigo there. You only use by parts if you see there's the two different in this case. In this kind of case, it's not by parts. Okay? No. Okay, that's good. Good questions. How do we continue from here? Well, that's differentiation. The normal method will be substitution of u equals to 3x minus 5. Stuff like that. Okay, I'm okay with that, but that's a smarter way of how to do. They have the same power, am I right? They have the same power. If they have the same power, then you can use this trick. What's the difference between denominator and numerator? So I would like to have minus 5 there, but I cannot minus 5 just like that in my life. I need to plus 5 back, so the equation will be the same. You have seen these tricks before. So 3x minus 5 over 3x minus 5 plus 5, 3x minus 5. This one also equals to 1 plus 5, 3x minus 5. Yeah, sorry, I need to be a bit quick here. There's one more thing I would like to explain. Personally, I will go from here to here straight away. Okay, integrating x, integrating 1. Integrate 1 will give me x. Okay, but integrating this one here, how do we differentiate this one? Do you see any x up there? X. Do you see any power down here? More power. Differentiate 3x minus 5. Give you 3. There's no 3 here, so what should you do? There's no 3 up here, what should you do? Times 3 over 3. Which 3 are you going to use? The up one or down? Up is the one that you want to use, okay? What should happen to the 5? You can take it out. This 3, you can take it out. So you got yourself over here 5 over 3. This is a bit fast. Advanced already. 3x minus 5. Integrate 1. X. Are you okay? Yeah, that's fast. I mean, I'm not going to teach you all over again. This one here. X ln 3x minus 5. This is minus, right? It will affect both of them. This one here is plus. This one here becomes minus. This one here becomes minus as well. Okay, over here it's just integrating ln. I'm going to end it with this one. Okay, you guys okay? I'm going to end this class with going back to the question just now. Can I move on? Can I? I'm going to end it with this. Okay, this is as usual. If you see x ln x, which is very pretty. Now, what about if I add this here? Definite integral. What will happen to the equation? What will happen to your work? There's no plus c, very good. There's no substitution here. I will personally write E1 back over here. Only once after I finish my integration by parts until the end, I'm satisfied with my works, then only I substitute the E and 1, which will give me the answer of E squared ln E over 2 minus E squared over 4. I will write them down, and then only I put this negative, only then I put the 1 minus ln 1, ln 1, 0, boom, minus 1 over 4. Okay? Let me write down this one, I sub E, this one I sub 1. Ln E, 1, boom. So you got yourself E squared over 2 minus E squared over 4, minus minus, plus 1 over 4. Are you still alive? Okay, so how do we do this one? Make the deno the same, equalizing the deno. This one becomes 2, this one becomes 4. 2 over 4 minus 1 over 4. 2, yeah, E squared over 4 plus 1 over 4. This is sufficient enough for your answer. Okay, but the question actually I'm doing here is actually a show question. It's one of your parts here. Are you okay? Right, I'll end it there. But for those who want extras, the question that haunted me last night was this. I'll explain in the next video. Goodbye. This is hard. This is super hard. I explain on the next video.